Alright, so part 2 is when a is greater than 1. So I'm looking at this guy right here. That's my a, right? We still know this is a, b, and c. So a is greater than 1, so I definitely want to use the x method. Okay? So let's try to do that. So a times c is negative 80. B is 3, and we're going to divide both sides by 2. So that's your setup. Alright, so in case you need to see that again, I have it in the notes, but that's the x method right there. Alright, so all our factors of 80 to give us 3. Now if you go through the list and you can't think of it in your head, I want to show you the trick in the calculator. Or I mean, you could Google it if you're at home. But if you're in class and you're using a calculator, all you got to do is go to your graph. And then I want factors of 80, right? Or negative 80, it doesn't matter, because we're going to switch signs. So on factors of 80, so I'm going to take that number, divide by x, and it'll press enter, and sometimes you don't see anything, sometimes you do. That doesn't matter. What you're going to do is press Control T to look at your table, and there are all your factors of 80. Okay, so I have to do the math mentally to get 3, whether adding or subtracting. So 4 and 20 is closed, 5 and 16. So actually this was a trick question because this one's non-factorable. All my factors of 80 do not add or subtract to 3. Here I get 16, here I would get 11, here I would get 2. And then once it starts repeating itself, you shouldn't go any farther. So actually, this one doesn't exist. This is non-factorable. We can't factor this out. Or you could just shorthand and say NF. Okay? So there's no factors of 80 that add to 3. So let's go to number 4. Let's do the same thing. 3 times 42 is 126. Divided by 3 on the sides and adding to 25. So same thing here, right? So I could just change this up here, do the same thing, go to negative, or 126 divided by x. Okay, so here's all our factors. We want to get 25. So I think 7 and 18 will do it. Okay, so 7 and 18. Alright, and then you divide them if you can, simplify. So that one can't, 7 over 3. 18 over 3 is 6. Okay, so you take those guys and put them into parentheses. For here, this is where you're going to do bottoms up. You're going to take the 3 and put it in front of the x. So that's what I call bottoms up. So instead of writing a fraction at the back, you're going to put 3 in the front plus 7 because it's positive. And that's your answer. Okay, so that's X method. All right, number 8. Number 8. So I have an A term and I have a C term. My B term is missing. I do not have a B. I don't have anything X, right? I'm missing that middle term that has an X. I don't have it. So you can do the X method always. But the shortcut for this one, since I'm missing B, is to take the square roots. These numbers should all be perfect squares. Okay? So if I take the square root of both of these, what's the square root of 49? Oh, it's 7. So I'm going to have 7 times 7. 7 times 7 is 49, right? It's the square root of x squared. Well, that's x. X times x gives me x squared. What's the square root of 1? I'm not really looking at the negative. I'm just looking at the number. Okay, the 1. The square root of 1 is 1. 1 times 1 is 1. And since I did the square roots, I actually have a positive and a negative. That's how my b value cancels out. So when you do the square root, you do a positive and a negative parentheses. Now, why does that matter? Why does the minus sign matter? Because this technique, or this special case, is called the difference of squares. And it's technically, I would say, even difference of perfect squares, because the only squares you can take a square root of are perfect squares. So the key is that it's different. Once I change this, and I'll try to trick you later on, once I change this to a plus sign, yeah, I can square root 64 and I can square root 9, but I changed it to a sum of perfect squares. You can't do that. It will not be the same thing, okay? So this would be non-factorable. If I put a plus sign in the middle of perfect squares, it's non-factorable, okay? So that's a trick. All right, almost there. Let's go to the back. Now, same thing here. I have two terms. I have A and I have B. What's missing? My C value. I have no constant at the very end. I have an A and B. Okay? So when you have a missing C value, you're going to be dividing. Okay? So division. Because if I have x squared minus 15x, I can divide both of these guys by x. Okay? So whatever I divide out has to go in the front one time, and then do the division for what's left inside. So x squared divided by x. If I have two x's on top and one on bottom, they cancel out. One of them does. So I have x left. And then 15x divided by x will give me negative 15. And that's your answer. Okay?